log out and rejoin the group with your students link. Okay. وحید رافع 2, وحید رافع 3, وحید رافع 4 and وحید رافع 5. Again, those friends that are present in the class with my link, please rejoin with the new link. Zahra, would you please share the link here? No, I mean, Hannah, can you share the link here? Oh, yeah, thank you. Those 3 friends, please rejoin with the new link. Okay, let's start. I'm start recording. Use this link. Okay, never mind. At the beginning, let's have an overview of the previous materials. In the previous sessions, I had very big chain notations, blocks, blockchain, proof of work, cryptographical hash functions, digital signatures, and the like were introduced very briefly. And I'm sure there are many questions in your mind. Okay? But that was a very big picture. That was a very big picture from the course. Now, each term will be discussed in detail. For example, now we start the topic 2. In topic 2, I will introduce the cryptographical hash function and the asymmetric encryption. So today topic is about cryptographical hash function. However, if you have any question about the previous lectures, please ask at the beginning of the lecture so I can continue after your questions. Is there any question? Okay. Since the internet speed is limited, so I don't share my picture. Okay, just let's share the slides. Later I will share this. I will send the slides through the forum or through the LMS. Okay. So we are starting topic two. In fact, I want to talk about cryptographic hash functions, and after that, asymmetric encryption and decryption. So let's start by parity checking and hashing algorithms. How can we tell that message, a file, a document, or something like that has not been corrupted? Suppose that you are downloading a file from the internet. Okay? Suppose that you are downloading a file from the internet. How error detection can be done? There are many solutions. One of the simplest solution is using parity checking. So let's see what's parity checking. Two kinds of parity checking can be introduced. One is odd, or the second is even. Suppose I will share this, and after finishing the session, I will share the PDF, the slide. Don't worry. Suppose that my message is a binary string like this: 11100111001. Parity is odd or even depending on the number of ones. For example, in the string above, there are 6 ones, so it has even parity. Because 6 is an even number, and if the number is divided by 2, the remaining must be 0. And for the 6, it's okay. So this message has a parity even. Now we can make a rule. What's my rule? All messages must have an even parity. For example, Alice wants to send the message 1101. The number of ones is 3. It's so 1 bit. Alice must add just 1 bit at the end of the message to make it an even number. So the Alice's message will be 11011. Okay? The main message was 1101. Since the number of ones was 3 and 3 is an odd number, we must add another one, just 1 bit. At the end of the message, now we have a message with even parity. Suppose that Bob is receiver, okay? When Bob receives 11011, checks the parity, everything is okay, there are 4 ones, so everything is okay, and Bob now can remove the last bit, the last one, so he can access to the main message, which is 1101. Now suppose that Alice wants to send 1001. The number of ones now is 2, and 2 is even. So if she sends the 1001, the problem will be that how Bob can understand that the message was 100, because Bob can consider that the last bit is for parity. Okay? So, in fact, in this case, Alice should send 10010. In fact, Alice must add just one bit 0 at the end of the message. So, Alice must send 10010. As soon as Bob receives this message, he can simply remove the last bit and the main message is 1001. And the parity is even, so everything is okay. This is one of the simplest way to check that everything is okay with the message, with the file. Okay, one of the oldest approaches. By this approach, you can just detect one error, or at least odd number of errors. For example, if my message is 1001, but in the middle of the process of sending, something wrong was happened and my message was changed to 0011, the parity can't detect such an error. So parity checking can help just finding odd number of errors. It also doesn't tell you where the error is, so you can't correct it. You know, parity checking is one of the simplest approaches. You can find just odd number of errors in a message. Also, you can't correct the error. Okay, so let's start talking about hash functions. What's a hash function? I sent you 3 short videos about hashing in general. If you watched those videos, I think one of the applications of the hash functions is cryptographic hash functions. It means that some hash functions which are in the cryptographic field, I think now you should be familiar with the topic. However, let's talk generally about hash functions. What's a hash function? H is a hash function. What's the input? The input of a hash function is a file with any length. What's the output? The output is strings of length n. It's called n-bit hash function. So input is any file length, output is a fixed length n. In the case of parity was just a very, very simple example. In the case of parity example, the function hx, its input is a sequence of bits, is a binary representation of a message with any length. So x is a binary string with any length. This h of x is equal to sum of bits mod 2. In fact, the remainder of division, sum of bits by 2. So it's a 1-bit hash function. The output is 0 or 1. Okay? So I started with the parity checking, which is one of the simplest examples of hash functions. Very, very simple hash functions, 1-bit hash function. But we can consider much larger ones. Hash functions have different applications. One of the applications is searching, fast searching. I suggest again, if you didn't watch those 3 short videos, please spend, I think, 15 minutes and watch those videos. So one of the application of the hash functions is searching, but another one, which is a totally different application, is cryptographical hash function. By cryptographical hash function, we can stop others from tampering our data. For example, we have a contract. We want to prevent others to tamper our contract, to change our contract. So we can simply publish the hash value instead of the main contract. In fact, we can hide our data behind the hash value. And for us, the security, one of the important points in the blockchain. Security is a very, very important issue. Suppose someone wants to defraud us, someone wants to change our contract to one more beneficial to them. But if we have published the hash value, or we have calculated the hash value, this will stop them from doing this. How? I will explain. Another important point is collisions. What's collision? If two different data, if two different inputs have the same hash value, if two different data, if two different input has the same hash value, we say it's a collision. For example, as a parity checking, h of 1001 is 0 and h of 0101 0 is also, as you can see, I have two different strings, 1001 and the other is 10110. In both cases, the parity bit is 0. So the output of the hash function is 0, and this is a collision, okay? In cryptographical hash function, it's very, very important that our hash function doesn't have collision. In theory, it's impossible. In theory, it's impossible to have a hash function that takes any input with any size but generates a fixed size output. The input is anything with any size, but the output is a fixed n-bit string, for example. I think it's obvious that in theory it's impossible, because your input space is infinite, but the output space is limited. So one of the properties of the hash functions one of the most important properties of the hash function, it should be hard to find two inputs with the same output. In fact, the function must be collision-free, but as I said, it's impossible. Another important property is that a small change in the input makes a large change in the output. Why? Because nobody can guess the function. We want to use these hash functions as a secure approach to secure our data. If someone can guess the function, if someone can reverse engineering the hash function, it's not a good function. There is an example here. Our hash function is age, in which the input is a person and the output is its birthday at first, number of day from 1 to 31, and after that number of months from 1 to 12. As you can check this, easily we can see that the input can be any people. There are many people in the world, but output is just 3065. Why? So output is a space with the size 365. Okay? Why? Because the number of days in a year is 365. So it's certainly there's a collision when the number of people grows up, and it's not a good function for cryptography. Another application of this kind of functions, hash functions, is fraud detection. How? Any changes in the data results in a different hash value. So simply we can prevent any tampering our data from the others by the hash function. Hash functions, which are called cryptographical hash functions. And these cryptographical hash functions are safe. What does this mean? It means that even though in theory it's possible to find two different data with the same hash value, but in practice, at least till now, nobody can find such two different inputs. Let's see some of the cryptographical hash functions. One of the simplest one is MD2. MD2 is one of the oldest cryptographical hash functions. In the there are many online calculators. Let's just to show you MD2 online calculator. Let me share my screen. Can you see this page? Yes? Just there are many online calculators for different cryptographical hash functions. You can simply say, okay, algorithm is MD2. I give the input my name, input. This is output. This representation format is hexadecimal. Do you know what is hexadecimal? In hexadecimal representation, each letter shows its, for example, this is the output, okay? This is the output. For example, the first D represents 4 bits. You can number 0 to 15. Okay, so 0 to is 3, but 10 is A, 11 is B, finally F. Okay, 3, 6, 7. Three, 4, 6, 7, 8, 10. 3, 4, 5, 6, 7, 8, 9, 10. 3, 3, 7, 8, 9, 10. 33. 33 multiplied is equal to 132 bits. It's 100 hash function. Okay. If I change one of the characters, now let me change one of the letters and compare. New function, the new is I just change one character, but totally different. As I said, these hash functions must have some properties. At first, collision. As I said, in theory, it's possible to find two different data with the same hash value, but it was very, very hard. And very small part of the input, there must be an exchange in the output. But the same size, every hash function, every cryptographic hash function generates a fixed size hash value. As I said, it's 132 bit hash function. It means that every output size, okay? Now let's okay, so there are many other algorithms. You can open it, MD4, MD1, prime. This is all the cryptographic hash function. First, coursework for you today is to have a historical research about cryptographic hash function which was until now. For example, MD2 was broken. What does it mean? It means that someone found at least two different data with the same value. There are many papers, different that are broken. Yeah, all of them are different algorithms. For one, all are different algorithms. Okay? But some of these algorithms were broken. It means that someone found two different data with the same hash value. There are different algorithms, so research, write an essay, 4 or 5 pages, just 4 or 5 pages about this. I will send into Telegram group. I will send the topic of the work, and there are different courseworks in the semester for this course, and all of them will be considered for your finalized mark. Okay, the best algorithm, I don't know which one is the best, but in Bitcoin, SHA-256 is using. SHA-256 is used until now. It's okay. Nobody could break this algorithm till now. I think one of the best algorithms is SHA-256. Many cryptographic hash functions. Some of them are very, very old and were broken. Like the family of SHA-1, SHA-2, family of SHA algorithms, secure hash function algorithm. It's for algorithm. Till now could out. Okay. Let's back to this slide. That was a very brief introduction to cryptographic hash function. Now we are talking about them in detail. What's the application of cryptographic hash function in blockchain? We want to use them to act as a proof of authenticity for a document of some sort. At least let's talk about different properties about cryptographic hash function to make this work. At first, the cryptographic hash functions must be public and computable. What's mean? It means that anyone should be able to use it. For example, Now you saw that I found an online calculator for MD2, SHA-1, and other different cryptographic hash functions. Not only there are many online calculators, but also you can simply find their codes in different languages in the internet. For example, if you search, you can simply find the Python codes of the MD2 algorithm. I will run that, and we can compare it with the online calculators. I mean, everyone, if want, he must can have access to this algorithm, and if he implements the algorithm, all the answers must be the same. Another property is computability. It means that this cryptographic hash function must be effectively computable and deterministic. Computability means that there must be a polynomial time algorithm for computing it. It means that, for example, an algorithm with complexity of ON or ON to the power 2, something like this. And deterministic means that each time we input a specific string, the output must be the same. For example, if the input is Vahid, for example, each time that I compute its hash function, the output must be the same as something that you can see here in the chat box. Another property is that H is a one-way function. What does it mean? It means it must be computationally infeasible to find X from H of X. So, how you can find the input by this output? You have the hash value. How you can reverse engineer it and find what was the input string? It's not feasible. So it's an important property because we want to use cryptographic hash functions as a security means. Okay? Another important property is target collision resistant. As I said, in theory, to find hash functions without collisions, in theory it's not possible. But in reality, it must be hard, very hard, to find two different inputs like X and X prime in a way that the output of HX be equal to the output of HX prime. As I said, the hash function in Bitcoin is SHA-256 and the output is 256 lengths. Another property is unruliness. It means that if you make a small change in the input, it results in a large change. X prime means another different input. You can say one input is X, another input is Y, and h of x must be different with h of y. It means that two different values must have different hash values. So another property is if you make a small change in the input, it results in a large change in the output. I think you saw that in my example. I changed one of the characters of Wahid and the output totally changed. It helps that nobody can reverse engineer the hash function and nobody can guess the hash function. As I said, in Bitcoin, the algorithm which is used is SHA-256, and the output is a 256 fixed length. Okay? Maybe you say 256 bit is not too long, so maybe someday someone can find two different data, two different inputs, but generates the same hash value. Okay? For example, you can say, let's have a table for every input. When we generate its hash value, we write both the input and the output in a table. For the new value, at first, we check the table. If in the previous, we have calculated the output, so we use the output from the table. But for the new values, we calculate the new hash value and we add them in the table. If I found two different values in the table with the same hash value, I can say, okay, we have collision. But till now, nobody could find such a thing. Why? Because 256 bit is a very, very large number. It's a very, very large space. Let's listen and watch a short video about how big is 256 bits. Can you? Okay. Okay, thank you. Let's start.
Oops. An important note, nothing is provably cryptographic hash functions.
Cannot prove theoretically, we cannot prove theoretically that there is any cryptographic hash functions without any collision. As I said, it's not possible because in theory, we have an infinite space of inputs with a fixed length. Is tried 256 is a very, very big number. Please watch.
Just that history is full of disproven attempts, but what we are to, and in fact, SHA-256 is actually used twice in Bitcoin. You use it and then you take the result and use it in SHA-256 again, and nobody's been able to find two things were not defined ways of doing. So we think this is so. For instance, it seems to be working as a cryptographic.
Till now, nobody could find two the same hash value with SHA-6.
I said before, the hash function SHA-256 it's quite clear from the name. It's 256. So
okay, so it's a 256-bit hash function. The output has 256 bits. No, hex digit is 4 bits, so 256 bits can be converted to a 64 hex digits.
256 bits long, and we write that as 64 hex digits. I guess the right word, but I don't know what it is. Okay, so it's 64 characters in a string, a 64 length string in hexadecimal. So it's not that long, but there's a lot of numbers that fit in there. Okay, so here's the two. It's not real as a thing, it's a sort of idea. Suppose we wanted 256 bit hash function that's completely cryptographic. What H could do is, if you give H of X, if H has been H of X has been computed at some point, and H of X will tell us what it is easily. It's already a bit of a problem. You can't really do that. It's too big a number, but that would be what an ideal random oracle would do. And if it's not been done yet, it says, okay, this isn't in my table. I haven't got a table. What I'm going to do, I'm going to up. So what I'm going to do is times, and each time I flip a coin, I'm going to write a digit 0, and then I'll get a new number, and that's now H. Now that doesn't mean no other number has ever had those random zeros and ones, that same coin flips haven't come up before. They may have done, but I have no way of knowing. Okay, it's not related in any way I can find that out. So, as I said, a lot of this just comes from the 256 bits there being a lot of 256-bit words. Reasons we don't worry about collisions are they're rare, but not computable because of all of the properties we've got. So how big is 256 bits? How many words are there? Now remember, for bits, the 64 hexadecimal, right? So it's not that long. You get it, right? Well, I'm adapting.
Okay. Here, used from this link, as you can watch.
These numbers from side. So that's 256-bit words is about 10 to the 168th. So if I was writing the number of 256 words, not one of these 256 words, but the number of them, using decimal notation, or using our usual notation, it would take 168 digits. Sounds pretty long. Okay, to give you a sense of this, in
2010, all the digital data in the world was about
recent result of this. All the data in the world was
just 3 bits, 27 to the power of 3 bits.
273 bits. 273, 2 to the 700, 2 to the 73 bits. 2 to the 73.
Sorry, all the data in the world was 2 to the power of 73. Okay, compare 2 to the power of 73 with 10 to the power of 100 and compare 2 to the power 73 over 256.
Less than 2 to the 256, right? If you 2d6 by 2 to the 273, you get 2 to the 100 and something. So, you know, it's if each of those 2 to the 273 bit.
He's trying to say that all the digital data in the world is less than, too much less, 2 to the power 256.
It was again 2 to the 273 bits. It will be getting any place near 2 to the 256 bits yet. And that's all the data in the world. There are roughly 10 to the 22 stars.
The number of stars in the universe is roughly 10 to the power of 22. To show you that how big is the (256) bits. In fact, even though it's a fixed number, very long.
Look how 22 divide to the 968 by 22, what you get to 10 to the 140 something. You haven't made a dent in that 10 to the 168 by looking at all the stars in the universe. In fact, all the atoms in the universe, turns out, as many people think, that 96% of us are dark matter. So let's put in the dark matter as well. What does that get us up to? Well, 96%, that's, what are you doing? You're multiplying by another 20 or something. So you get 10 to the 85. Nothing like 10 to the 256. Part of those that can be written as 50. Okay, maybe with this YouTube video, which is a really interesting take on how big. Thanks for this.
Okay, if you like, you can watch this YouTube video to know about how big is 256. Okay. Now, let's with Python implement some very simple programs and graphical hash functions. If you okay, there are many applications. Here in this course, we want to use and we want to be familiar with blockchain. Okay. Let me make it okay. Today there are many cryptocurrencies like Bitcoin, Shiba, and many others. Okay. Without cryptographical hash function, it's not possible. So we can say, for example, one of the application. So you ask, what's the benefit? One of the benefit is Security of cryptographical hash functions. Yeah, no slide. I know. There is no slide now. That slide was finished. There are different. One another is security. If you use Gmail, your and other emails, okay, our email, our password, everything was hashed, and after hashing, our messages, our passwords, our data goes through the internet. There are many benefits. Without, let's short this part. Without cryptographical hash functions, without them, this internet, today internet, I'm sure that didn't work. You can't pay, you can't have any online payment without cryptographical hash functions. There is nothing secure in the internet without cryptographical hash function, okay? Last week, I loaded Python, and I want to implement some simple programs. So if you didn't yet, please search Anaconda, download it, and install Python Anaconda. And after installing, I use Jupyter part. So let's use Jupyter, some brief explanation about the environment. When you run the Jupyter, something like this, an explorer will be open, okay? This is the result of running Jupyter. Here, you can new a Python file onto you. Here, place your instructions. For example, I3 print. To run the program, just press this run button here, as you can see. Now, there's another, you can write the second part, as we say that, okay, this is the first part, first block, second block for I+1, again, this is the second block. About the syntax, pick up. It's something like some are similar to Java or C, but it has its own syntax. For example, this is a simple loop for I. In range 5. Python, we don't have or end and close, okay? Instead, Python uses indentation. This starts from, okay? The commands with the tab are considered inside the for loop. So if I write something like this, print I. This is outside of the loop. Run. We need a space here. Okay. Outside the loop 0, 1, 2. Outside the loop, we have last value of the I, which is 4. This is the Jupyter. This is the Python. If you are not familiar with syntax and semantics, simply search and study about that. It's complex. It's very, very simple language. And if you search MD2 Python codes, you will find this code, this program. Explain, who cares? I found code that I can't care. I want to run the code. If this is D2, okay? If I run it, the input Vahid, this is the output, okay? So the hash value of Vahid by MD2 algorithm is this string. If you online of MD, so today Vahid encode. Okay, if I copy and now compare the output, see the output of this program is the same as this, and it must be that implement the algorithm must generate the same value. Or if I run again now, simple change in the input, adding 1 at the end of the string, we have this output. As you can see, the output is totally different with this one. Okay, next. Session, which I'm trying to record it by tomorrow. I will try show you how to use other functions, especially SHA family, SHA1, SHA100. I said in not in Bitcoin, but also in many other cryptocurrencies. SHA-256 has an role in the security of that cryptocurrencies. So for now, I think it's sufficient. Please let me know. Session, as I said, I will continue programming with Python and how to implement and not implement, but how to use different cryptographical hash functions, introducing the libraries and the like. So now we have a coursework. You have 2 or 3 weeks to send the essay about historical research about cryptographical hash functions that were broken till now, like MD2, but not only MD2, but also there are many others cryptographical hash functions that were introduced till now, but were broken till now. Thank you very much. No question? Okay, see you later. Bye.